tell me a little bit about yourself. Where are you from?
Well, I grew up on the East Coast. I was actually born in Baton Rouge and lived in Jersey and went to University of Virginia undergraduate and Stanford University graduate. I've been working for a long time. I'm a lot older than I look. So I've been working in the computer industry for about 25 years. Started off in artificial intelligence, and then started a company. I've started two of my own companies. I've been at 3 or 4 other startups. And most recently I was at Yahoo for 8 years, holding the role of Chief Performance Yahoo.
Okay.
And now I'm working at Google.
So you made your way from artificial intelligence to web performance. Fantastic. Just curious, when were you in artificial intelligence? Which years?
That was 84 to about 89 or 90.
So you a Lisper or a Prologer?
Yeah,
or,
yeah.
okay.
Symbolics machines. I convinced my dad to buy some stock in Symbolics, and he's never forgiven me for that.
Okay, well that's fantastic. So your studies were always computer science, mostly?
Yeah. Well, both my degrees are in systems engineering, so it's more large-scale systems, decision making, decision analysis. Things like that, but always with a emphasis on computer systems, computer architecture, computer programming.
Wow, fantastic. And you just wrote your first book?
Yes, this is my first book.
It's High Performance Websites.
Very thin.
Very thin. That's
you can
the
read
way
it
I like
easily.
them. Who is this book meant for?
Well, there's a discipline that's existed in web development from the beginning, but is getting a lot of attention now, and I call them front-end engineers, or F2Es is a acronym coined at Yahoo. I saw it used most at Yahoo. And so it's people who are working on building websites, but they're more focused on building the actual page and the delivery of that content, building large databases, large caching architectures. At Yahoo, I ran my Yahoo team for 3.5 years. And whenever people would talk about the performance or slowness of a website that I worked on, I would look at back-end optimizations. I would go in and I would see how long are the database queries taking, how many how many requests per second are we getting off.
Okay. So that brings up a question. So how do you actually measure performance, and what are the common metrics that are used to measure them?
Well, so from that work, focusing on back-end architectures, when about 4 years ago I started the role of Chief Performance Yahoo, I realized that what we really wanted to optimize was the end user experience. And so when I actually fired up a packet sniffer and saw how long it took pages to load from the end user's perspective, from the browser's perspective, that's when I discovered this thing I call the performance golden rule, which generally across almost any website you go to, only 10 or 20% of the time the user is waiting is spent getting the HTML document, the dynamic content from the web server.
And where is the rest of the time being spent?
So in that page, in that HTML document that gets delivered, there's things that the browser has to do with that. So there's HTML, the browser has to parse that. But there's also CSS and JavaScript that the browser has to parse and execute the JavaScript. And then there's also all the other external resources, the images, external style sheets, external scripts that the browser has to download. And the way browsers are built, the way the HT spec is written, is there's a lot of kind of weird interactions in how the browser performs what the HTML document has told it to do. And so your question was, so what do you measure? And so this was the thing that kind of flipped the perspective on performance upside down. Instead of focusing on the back end, which people had done historically and still do, I see that a lot, I was saying focus on the front end where 80% or 90% of the time is being spent. So when we look there, what we really need to do is look at how long it takes from the point the user makes a request to the point that request is done loading in their browser. So the overall page load time. As opposed to, I think, what a lot of companies historically had been looking at was how long did it take my web server from the point where it picked up a request to when it delivered either the first or last packet.
Okay.
And that's important also, but the difference there is I kind of break performance into two areas, efficiency and response time.
Oh, okay.
And efficiency is more about how can I reduce the amount of hardware, the number of servers I need, but response time is more about how long does the user have to wait for this page to load.
Oh, okay, interesting. So also that which plays into that is scalability.
Yeah.
How well does the system scale?
Yeah.
So any tips there?
Well, that's really
That's more back end, right?
Yeah, that's more the efficiency side, right? Is if you take a long time to serve the HTML document because you have slow databases or your code is bloated or inefficient, then that's going to affect the response time. But actually, it's not going to affect the response time that much.
Okay.
Like even if you doubled the amount of time it takes to serve the HTML document, you're still going to have 50 to 80% of the time taken up by the rest of the stuff in the page.
Right.
So scalability is going to be more of an issue, not with response time, which is my area of focus and what the book talks about, but it's going to be about how to drive down hardware costs, and when you drive down hardware costs, you drive down rack space that's needed in your data centers, power consumption, and all of those things are critically important, especially for large companies like Yahoo and Google.
Yeah.
But it's really not, it's almost completely separate from response time from the user's perspective. When we look at latency and how browsers load different components and how long browsers take to parse JavaScript and execute JavaScript and apply CSS and manipulate the DOM, that's completely unaffected by the scalability of your website.
Can you explain what latency means?
Yeah, so generally people use the term latency to mean how fast or slow something is. Mm-hmm. More specifically, latency means the time from when a message or piece of data is sent to when the first part of that arrives at its destination. Okay. And so when I use the word latency, that's really what I mean. And what I mean there is, especially for people in parts of the world that are emerging markets, Southeast Asia, for example, even for companies like Yahoo and Google that have data centers distributed around the world, there can still be a large amount of time between when the browser sends a request, when it leaves the user's machine, to when that request first hits the Google or Yahoo or whatever web server.
I see.
And again, a large latency from when the server sends the first byte of its response to when that arrives back to the browser. And so, if you have, for example, one of the best practices or techniques that I talk about in the book is spriting, where you can take a bunch of CSS background images, maybe you have 20 background images in your page, you can load those all into one image. And so and that's called a sprite. Oh, and so if you do that, you change from imagine this person sitting in Indonesia. Yeah. Now their browser only has to do one HTTP request as opposed to 20.
And that's to reduce latency.
Right, because if they have 200 milliseconds latency for each HTTP request and you're doing 20 HTTP requests, that's going to be kind of big, whereas if you just do one HTTP request, the latency is going to be less of an impact.
I see. You also talk about 14 rules on how to improve response time.
Yeah.
And can we just talk about a few of these rules right now? I know that this is a very long, each one is a very long topic, but maybe we could just touch on a few.
Yeah.
Okay. So make fewer HTTP calls is your first rule.
Yeah. In the book, the rules and the chapters are done in priority order. So the ones that are first are kind of the most important. Okay. And so like we just talked about, on average now across the Alexa top 10 websites, there's an average of, I forget the exact number, 40 or 50 HTTP requests that are done. Okay. And so each of those, and there's a way that the browsers work, that the HTTP spec is written, that for HTTP 1.1, there should be no more than 2 open connections per host name. So for example, if you're serving 40 resources, images and scripts and style sheets off your server with one host name, then it's going to take, suppose you have 20, it's going to take 10 steps or phases to download all 20 of those. So if we imagine that each of them take 100 milliseconds, which is actually pretty optimistic, You can only download the first 2, so that's 100 milliseconds. Then the next 2, next 2, next 2, next 2, next 2, next 2.
Okay.
So you get this stair-step pattern.
Oh.
And so that's why reducing the number of requests is really important, because you could have, for example, we just talked about sprites. You could have that sprite request, and while that was going, some other style sheets or scripts could also be downloading.
I see.
So you reduce the number of requests, you reduce that overhead, and this is especially important for people who are building websites for a worldwide audience, because you're going to have these people again who are in areas where they have high latency.
But that rule that you just, the first rule, it just doesn't have to be for really large scale websites, is that correct? Like the Yahoos of the world. I mean, what if you're a small company, small business, you just have one single server, IIS running or Apache, these tips will still help, right?
Oh yeah.
That rule is still very applicable.
Yeah. If I, so I don't know if we're going to run over or not.
It's fine, we have
But
an
there's
hour.
a good anecdote here. There's something, I started at Google in January, and I was really kind of proud. In February, I was at South by Southwest, and that week, Google announced that they were adding, there's something with Google AdWords called the quality score.
Okay.
And this is a algorithm that computes a score for advertisers that is a factor in how that advertiser's ad gets placed in the Google search results page. And Google announced that another ingredient in that secret sauce for computing quality score was going to be the advertiser's page load time. So how fast or slow your page was going to affect where your ad got sorted. And when I mentioned this to people at the conference, they were like, wow, that's really exciting, that's really cool. And usually after 15 or 20 seconds, I would get the same response. But isn't that really kind of unfair for Google to do that? Because it's giving an advantage to large companies who have the resources to work on these performance improvements. And my argument is it's just the opposite. These performance improvements are pretty small to make. Modify your web server config, rearrange some of the resources in your page, take 10 images and combine them into one sprite. They're pretty easy changes to make to your site. But when you look at a large company that has a lot of legacy code and large teams working, it can take them weeks or months
to even identify the problem,
to get the change through all of the build processes and teams in the company.
Okay.
So actually, I think that the best practices espoused in my book are easier for small websites to implement than large companies.
So, just to follow up on that, did Google do that placement for a technical reason, because it's faster to load the components or the ads?
No, because when you load the ad, it has nothing, it's not impacted at all by how fast or slow the page is that you land on when you click on it.
Okay.
What Google is trying to do, and it's very cool, is Google wants to make the experience for all users on the internet better. And Google feels that if you put a link closer to the top and the user clicks on it and they have to wait a long time for the page to load, that does not promote a good experience for the user,
So
kind of independent of whether it's of Google or anyone else. So to promote a better user experience, let's promote sites that are fast.
Which
of course is great for me.
It's like, I mean, you'll be in business for a long time, but also it's like a Darwinian ecosystem, and only the fastest survive. So another rule that jumped out at me, and it's actually rule 2, and it never occurred to me, but I thought it was just brilliant, was using a content delivery system. I bet a lot of people don't really even know what a content delivery system is, so can you talk a little bit about that?
Yeah, the idea is that it can be challenging for, so if you have all of your servers in California and you have a worldwide audience and you have users from the East Coast or Indonesia or China coming to your site, that's a long way to come to get resources. So, what you could do is a company could look at building out data centers around the world. Now, for a company of Google size, that is something that's actually feasible. But for most companies in the world, let's face it, they don't have the resources to do that. And so one thing that would be challenging would be to deploy your application logic across multiple data centers and deal with database replication. And so the advice of that second rule about using a content delivery network is to actually not try to deploy your application logic, for at least not to attempt that first. So have all your application logic on a server in California, that's fine.
Okay.
Because there's only one request that's going to go to that server, and that's the HTML document, where you have to look up the user's preferences and personalized data. But now that page is going to include static resources, images, style sheets, scripts. Those static resources could be served by a local service provider. So in the content delivery network industry, there's Akamai and Limelight and Savvis and Panther Express and a couple others. And it's it's pretty easy technically. There's not a lot of technical hurdles to get those service providers to host your static content. And now all you do is you use a different host name that points to that service provider. And the service provider, because they have the economy of scale, can build out these data centers around the world. And so now your users in China and Indonesia, when they have to get those 20 background images or other assets, resources in the page, can go to a data center that's geographically closer to where they are.
They can just tell by the IP address, this is an Indian user. I never really thought of that. I guess, is there a way to measure the effects of remote servers? I mean, is there a metric that you use in the industry to sort of tell, to measure how much faster it would be to, say, hit a local resource versus something on the other side of the earth?
Well, it also depends on the actual servers that you're going to. But people will look at ping time. They'll look at and that's basically the latency from one geographic location to a server somewhere.
I see.
But generally, what you're going to find is the less geographic distance, the faster the experience.
Okay. One rule that sort of really surprised me when I first looked at it was avoid CSS. There's a lot of how is that possible? How can you avoid CSS?
Okay, so technically the rule is avoid CSS expressions. And so expressions is in addition to the standard CSS that only is available in Internet Explorer. And it lets you to actually embed a little bit of JavaScript in your CSS. And that's kind of powerful. It makes it a little easier to attach behavior to elements in your page without having to deal with event handlers. But the problem is people don't realize how often these expressions are evaluated. So for example, every time you move your mouse in the page, even every time there's a mouse movement event, the expression is evaluated. So it's very easy to get a JavaScript expression that's evaluated 10,000 or even 100,000 times just while the user's viewing the page as they scroll and move the mouse around. And so if you've written an expression that isn't really efficient, that could really bog down the user experience.
I've personally experienced that many times in all my websites. Are there tools that you recommend that people use to sort of do performance measurements on websites? Are there some standard tools that exist for doing that, or is it just sort of a hodgepodge of various sort of pinging and putting timing statements in your backend code? And how do you approach it?
Well, one thing that's so I've got a two-part answer. So, one is you want to see what's happening in your page and you want to see timing information. And so you can use packet sniffers. Firebug has a tab in it called NetPanel, which was a little buggy in Firebug 105, but I believe it's been updated in Firebug 1.2. Or you could use more traditional packet sniffers like HTTP Watch, AOL Page Test, Fiddler, IBM Page Detailer, and those will give you what's sometimes called a waterfall chart. It will basically give you a graphical representation of all of the HTTP traffic in your page over time, and so you can see what's taking a long time and what's not, and that's really interesting sometimes, but it can lead to some incorrect conclusions, because what you're doing is you're getting some time measurements for you, right? And you don't necessarily represent the diversity of your user population.
Yeah.
And so, especially a lot of
Sure.
times companies, the people working on a website are very close to one of the data centers that that company runs.
Yeah.
And so it's very likely that you're going to have very low latency, very short ping times. And so people, I see this a lot, developers are working on things on their company network, which is probably faster than 98% of their audience. And they think that it's fine, it's pretty fast, it doesn't seem that bad. And so, so you can use packet sniffers like that to get measurements. But what I found was people who are developing websites, when they do that, they're really not getting a statistically representative set of measurements.
Also, if they're doing it in a test environment, that's another thing. And if it's a new website and it's early on, maybe a lot of people don't even know about it, and so you don't run into these problems until it becomes more mature and it's in production. And
so there's another software product that I could recommend, and it's kind of fun to talk about today because I announced it a year ago here at OSCON.
Yes.
And that's a tool that I wrote called YSlow, the letter Y, SLOW. So if you just search for that, or you go to developer.yahoo.com/YSlow, you can download it. It's an add-on to Firebug. And when you click on it, it tells you the things that the specific things you could do to your page that would make it faster. And it actually runs on any page. You can run it on any page that's in your browser, you can run YSlow on it. And basically the way it came about was I had this role at Yahoo to go around and evangelize performance, to do research to find out what are some performance best practices, and then try to preach the gospel to all the development teams at Yahoo. And I found that I'm one person and there's hundreds of teams and I just can't scale.
Sure.
And so I had two answers to that. One was to write the book, and the other was to codify the knowledge in the book in a software product, and that's what YSlow is. And so it was awesome that Yahoo was willing to release that as an open source product a year ago today. And so anyone can download it and run it on their site. And when you run it, it tells you these things don't have a far future expires header. You have 20 CSS background images. You can try spriting. And if you click on the link of the rule, it will actually take you to about a one-pager that explains the logic behind that. And then if you buy the book, you actually get a chapter about each of those that expands on the one page. That gives you more background.
This book? Okay.
So it's kind of a companion piece of software to the book.
Oh, that's fantastic. So you have 14 rules in here. So is this all there is? I mean, I go through these 14 rules. I sanitize my website, and is that all there is?
Yeah, you're done. You
done?
You can go home and ask your boss to take the rest of the year off.
Okay.
No, I really feel like there's a lot of interest in the last year or so around performance and scalability, both of these topics. And I think there's a couple things that are driving that, but because we are at the tip of the iceberg, the research that I'm doing and that other people are doing is really kind of just beginning. And so the book and YSlow are the results of my years at Yahoo as the chief performance Yahoo, and my work at Google has continued, and so I've done more research on performance best practices. In fact, I'm starting another book. And I've written the first 4 chapters of that book. And I think that the best practices that are measured by YSlow and that I talk about in my first book are really, really important. And that's really the place to start. And a lot of those fixes are pretty easy to make. But I also feel that the word about those best practices is getting around and gaining traction. And so what I see for the future, especially as we move into Web 2.0 and more DHTML, is JavaScript is getting really big. And so for the next year or two, that's what I see is really going to be the area of focus for faster page load times.
And your new book talks a lot more about those.
So the first 3 chapters I wrote are about JavaScript performance, and I'm doing a talk tomorrow here at OSCON, and it's basically summarizing the best practices out of those first 3 chapters about how to load and get your JavaScript to perform faster in your pages.
Okay, well, so that builds off of this book. It's a good companion book for the conference velocity. Do you want to talk about that a little bit and how that relates to your work?
Yeah, it's really been an amazing year this past year. I got the book out. We released Why Slow, and actually a year ago at OSCON, I had a meeting with Tim O'Reilly and Jesse Robbins, a person. Jesse's really well known in the scalability ops area, and we met with Tim and we discussed the need for a forum for engineers who work on operations and performance to gather and share their expertise and lessons learned, and he agreed, and so out of that came a conference called Velocity. We just had it about 3 weeks ago, and it was a huge success. We had about twice as many show up as we expected. Great speakers, great content. And we have it scheduled to run again next year in San Jose at the end of June. And so yeah, it's just performance is really catching on, and it's really important for the future of the internet.
Another question: since your background was in AI initially, do you see now with the semantic web and more AI topics maybe resurging? They sort of, not many people talk about AI anymore, or expert systems, but I mean, do you think that there may be a resurgence there in the next 5 or 10 years?
I don't know. I mean, I think you're seeing some of that. I like seeing some of that in programming languages.
Yeah.
Things like Alice, where not necessarily natural language, but trying to make programming a little more approachable. I think that there would be pretty widespread agreement that the language of programming computers is not very similar to the way that people communicate and use language. So I think there's some there, and certainly things like data-driven execution, I think, is something that came out of AI, or certainly that's where I really learned that. And I think you see that being deployed a lot. But some of the stuff when I was doing AI, I worked on the autonomous land vehicle project, where auto-driven cars that were driven by computers. And
what was that with NASA, or
that was with DARPA?
DARPA. Okay. Yeah. Wow.
And so I think some of those far-out AI things, I don't see those being used in
I noticed that there has been a resurgence in functional languages, especially with Ruby and Python. And when I think about functional languages, I always think about Lisp jumps out at me, and like a lot of the ability to do macros and metaprogramming, and that's sort of, from a programmer's perspective, I think very close to a lot of AI concepts. So I'm just wondering if maybe you see some of that maybe taking hold at Google, or I mean, I know that Google is famous for MapReduce frameworks, but
well, I think JavaScript is a highly functional language. I mean, it has some high-level features,
first-class functions,
very reflexive, and so I think we can see. I think more will be done with that as we move forward, and certainly here, it's great being here. A lot of the big names in web technology are here at OSCON. I think you will see some of those kind of advanced language capabilities being, leveraged more.
Yeah.
But no, I'm not relying too much on my AI background these days.
Okay, well, great. Stephen, thank you very much. It was a pleasure, really a pleasure to talk with you. And
thanks, that was a lot of fun.
Yeah, and we're looking forward to the next book, and obviously this one.
Yeah.
So, thank you.
Thank you.